Hey, it's Yusuke here. In this video, I'm going to go through what is HPC and when to use HPC and the architecture of a HPC cluster. High performance computing is about solving computationally heavy tasks faster. An HPC cluster is basically made up of small computers, and these small computers are connected together to create a large computational resources. And the same thing can go for Fugaku, which is the fastest computer in 2020. As you can see on the left chart, Fugaku has absurd number of cores and memory. HPC can be used in many applications such as self-driving, genomics, and some financing. HPC is used when the program takes too long to process or the dataset is too large to fit on the computer. And here's the architecture of a HPC cluster called Massive. And the whole purpose of this is to run your program on these large computational resources. And the way to do it is that the user would have remote access to login node. And here's where you prepare your source code. And so you can send a job to Slurm, which is the scheduler. And this scheduler assigns job to these compute nodes to run your program. And the key in HPC is to write a parallel computing code that utilizes multiple nodes at the same time. Essentially, more computers, faster your code. And I'm going to go through each of the components of HPC cluster in more detail. Starting from login node. So login node is where user manages the workflow, like sending jobs to schedulers. And multiple people can share the login node at the same time. For Massive, about 100 people can be on login node at the same time. However, the computational resources on login node is not huge, so you really need to be careful when you run your programs on login node. Moving on, we have compute nodes. Each compute nodes have CPU, RAM, some disk space, and even GPU in some cases. And you get the access to compute node through scheduler, and you should always run your program on login node. Lastly, I also want to touch on scheduler. And Slurm is a software Massive uses as a scheduler. And Slurm can do these three main things. So Slurm can allocate resources to users, and it can provide a framework to start, execute, and monitor jobs. And Slurm also manages a queue of pending jobs. And Slurm can be think of a game of Tetris. So let's say this yellow block on top is your job. And this can run when there's enough computational resources on compute nodes. But sometimes it needs to wait before there's enough space on compute node. And that's what Slurm does, is sometimes queue the job until there's enough computational resources.